Hello, everyone, and welcome to Algebra 2. This is section 9.6, Modeling with Trigonometric Functions. So today we're going to learn about frequency. Frequency is the reciprocal of period. So it's a pretty simple definition because if you know the period, then the frequency is the reciprocal of it. Or you could write it frequency, reciprocal of period. Either way, it would be the same. It tells us the number of cycles per unit of time. We'll jump straight into an example, and I think you'll understand it. A sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. An audiometer produces a pure tone with a frequency of 2000 hertz. The maximum pressure, P, produced from the pure tone is 2 millipascals. Write a sine model that gives the pressure P as a function of time. So we want P of T, and they want it to be a sine model. So I'm going to write A sine of BT. We won't worry about shifting it left, right, up, or down. There's no reason not to have it start right at the origin. So we only need to find A and B. So remember that A stands for the amplitude, how high and low it goes. Well, they actually gave you this answer right off without having to do any work. It says the maximum pressure, P, produced from the pure tone is 2 millipascals. So the highest it's going to go is 2. So now I know that it's P of T is equal to 2 sine. And I need to find that B. So remember what we used B for. Since the normal period of sine is 2 pi, if we divide by B, that'll give us the period of our function. But we know that frequency is the reciprocal of period. So you could say that frequency is B over 2 pi because it's the reciprocal. So since they told us that the frequency is 2000 hertz, B over 2 pi, I can find B. B is equal to 4,000 pi. I got that from clearing the fraction. So now I can fill in B, 2 sine 4,000 pi x. Although it is in terms of t, so I'm just going to go ahead and erase my x there and change it to a t. That's what that means when it says as a function of t. T is the thing that you're giving it in order to calculate, in this case, the pressure. So of course that was a word problem. We are going to try just a couple basic ones to make sure that you got the hang of it. So write a function for each of the following, and these are pronounced like the word sine, sinusoid. Sinusoid. So we're going to write the function for each one. Now I notice that this one starts high. So even though it's called a sinusoid, it could be sine or cosine. You are not required to shift. So since this one starts up, I know that it's going to be y is equal to a cosine of bx. And this one also starts up. So this one, again, even though it's called a sinusoid, it's still going to be a cosine because we don't want to have to shift it. So A is the amplitude. So what you want to do is find the midline. Just kind of cut it in half. And then I can see it goes up to 5 and down to -5. So its amplitude is 5. Now to find B, remember how we use B. We usually say that since the normal length of cosine is 2 pi over B is going to give us the period of this particular graph. Well, let's take a highlighter here and highlight one period. So if this is one period and it ends at pi halves, then 2 pi over B must, whatever B is, it must have come out to be pi halves. So, of course, I'm going to clear my fraction. I multiply both sides by 2 to clear this, and I multiply both sides by B to clear that. And I get 4 pi is equal to pi B. Divide both sides by pi, and B is equal to 4. So that's the number that must have been there that created someone to get the the length as being pi halves. All right, let's do that for this one now. Remember, your first step is to find the midline so that you can see how high it goes. It goes up to 2, and how low it goes, down to -2. So my amplitude is 2. I write cosine. I just need to find that b. So I write 2 pi over b is equal to the period of this function. So I just kind of sketch it out. I see where it starts, and when it gets right back to where it already was, that's 1 period. And in this case, that is 2 pi thirds. It finished by 2 pi thirds. So again, I clear my fraction. I multiply both sides by 3b. On this side, that'll clear my b. On this side, it'll clear my 3. And I end up with 6 pi is equal to 2 pi b. And then I divide both sides by 2 pi. And I get b is equal to 3. All right, there's one more of these. So this time, a little bit trickier. Find the midline. So I go like this, and then I feel like I've cut it in half. So if this is the midline, then I'm going to have to think about this as my 0, 0, which means this graph has been moved up 2. And because it starts at 0, unlike the other ones that started above, this one's going to be a sine. So a sine b x plus 2. So how do I find a? I just, again, see that it goes up to 5, but it's not 5 because it only goes down to -1. Remember, amplitude is this distance here. So going from 2 to 5 is only 3. Y is equal to 3 sine of something x plus 2. So again, I get my highlighter out, and I find one full period. So sine goes like that. It comes down. And now I've completed one. If I went any further, I'd be starting the next cycle. So where did I end? Oh, they didn't tell you this time. It's not as obvious. So if this is pi and there's 4 divisions, this must be pi halves. So 2 pi over b made the cycle come out to be pi halves. We can solve this. Clear the fraction by multiplying both sides by 2b. On this side, the b's cancel. On that side, the 2's cancel. And I get 4 pi is equal to pi b. And b is equal to 4. All right, let's do a word problem. 2 people swing jump ropes, as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, and the lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height in inches of a rope as a function of time t, given that the rope is at its lowest point when t is equal to 0. So I really don't know very much at all. So I'm actually just going to write h of t. I don't know yet what its amplitude is, its period, or even if it's sine or cosine. Probably the easiest thing to do is to actually put it into a graph. So we know at time 0, it's 3 inches above the ground. And then it's going to go all the way up to 75. So it's going to go up and then down, and then up and then down. So now that I have it in a graph form, I can think about its midline. So if to go from 3 up to 75 is a total distance of 72, which means halfway, this must be 36 and 36. So now I have an amplitude, 36. And because it doesn't start at 0 at the midline, it starts below or above it, it's going to be cosine. And because it starts down, remember that cosine normally starts up and then goes down, it's going to be flipped. So it's negative. And because it didn't start below because the midline isn't the x-axis, the whole graph has been shifted. How much? Well, this 3 and then this 36. So it's been shifted 39. So all I have left is to get this b. Remember that 2 pi over b is equal to the period. So the question is, where does it finish this cycle? How long is this time? Well, what they did was they gave it to me as a frequency, 2 revolutions per second. So remember that if the frequency is 2, then the period is the reciprocal of the frequency, so it's 1/2. 1/2. So now I can clear the fractions, multiply both sides by 2b. I know you're getting sick of my explaining this, but I really want you to be great at clearing fractions. It'll help you so much. Is equal to b. And so that's what I'm going to put in there, 4 pi. And I know it looks funny to have the pi in the equation. We don't always have that. But that's so that they can plug in time instead of an angle, which is what we normally plug in. So now we're going to do regression. This year we've done linear regressions and quadratic and exponential regressions, and now we're going to do a sinusoidal regression. The table shows the number n of hours of daylight in Denver, Colorado on the 15th day of each month, where t is equal to 1 represents January. Enter the data into your calculator, make a scatter plot using an appropriate window, perform a sinusoidal regression, and write a model that gives n as a function of t. So we are going to enter all this in, but while I have the data in front of me, I want to just talk about the window. So the x min, remember that this is going to be your x and this is going to be your y. So when we get there, we're just going to go from 1 to 12. And if your scale is changed at all for any reason, you just would want it to count by ones. For your y min, we really don't need to go below, what's the lowest one? I think this 9.38 over here, but I still usually just like to start at 0. And then y max, I don't see anything higher than this 14, but I could either go to 15 or even 20 just so that I can see it clearly. And then of course, same thing. Your y scale can just be 1. Okay, so the first step is to go to Stat, and then you want to edit whatever lists are already in your calculator. Once you've cleared them out, you can enter in the new data, which to save you're watching some time on this video, I already did. And then once you've got your lists, then you can go to Stat Plot, so second Stat Plot, and you can turn those plots on. So you just want to hit Enter, and then Enter again, and now you can quit out of that. That turned it on. Check your window, which like we said before, we're going to do 0 to 12 and then 0 to 20. And now you can hit Graph. Now I see some other kind of line in there. That just means that I still have something in there, so I'm going to clear that out. And when I hit Graph, there I get, oh, I can definitely see the sinusoidal shape of it, right? Except I'm thinking that if there's a midline there, that you could call it cosine. So since I think our regression is only going to do sine, it's going to have to shift it, which you don't have to do. You can just start it with cosine. But when your calculator does it, we don't care if it shifts or not. So let's go ahead and do that regression. I go to Stat. I want to make a calculation. I go down to the sine regression. Keep going. Keep going. There it is. Okay, so it's definitely going to do sine. It's not going to do cosine. And you can just leave whatever is there. Just go straight to calculate, as long as it says list 1 and list 2. And there you go. It gave it to you. So you can fill in all these pieces. 2.76 is going to be your A, and then there's your B. See, notice they did a C, which shifts the graph, and then a D, which is going to go up 12. If you go to y is equal to 2.765 sine of 0.511. Now technically it's t, but I'm going to write x. And then 1.591. These are the numbers that I just got off of my regression. And now when I hit graph, look at that. It goes right through it. It's perfect. The last step just said interpret the period of the graph. So remember that the period is 2 pi over b, which for this one is 2 pi divided by 0.511. And if you do that on your calculator, you'll get approximately 12. Does that make sense? I hope so, because that is the length of it. And then after the 12 months are done, then the cycle, the year, would repeat. And so that's why the period comes out to be 12. All right, that is it for section 9.6. Have a great day.